Hello, everybody. It's Mrs. Pound, and we are finishing chapter 7.3 today on the sun, the earth, and the moon. And we're going to finish by talking about the seasons from section 734. So, our objectives today are going to be to model the way in which Earth's tilt and revolution around the sun cause different seasons, identify Earth's primary lines of latitude, and differentiate between a solstice and an equinox. So, Earth's northern and southern hemispheres experience changing seasons because the Earth's axis is tilted at a 23.4-degree angle. And you see that with the globe. That's why all of our globes are always tilted because the angle of the Earth is tilted. Its axis is tilted between north and south poles. Um, and this is what causes our seasons, but that and the revolution around the sun. If the earth was perfectly up and down, we would not have seasons. So during the Earth's revolution around the sun, the northern and southern hemisphere take turns receiving more direct sunlight and greater warmth. So if the sun were, say, over in to the left, okay, if it's over to the left, we would see that the northern hemisphere is tilted towards it. And so that area would be receiving more sun and it would be summer. If the sun was over to the right here, now, and it would be winter in the southern hemisphere. If the sun was over to the right here, the bottom part of the earth is tilted towards the sun. The southern hemisphere is receiving the most direct sunlight. It is summer and it is winter in the northern hemisphere. So let's talk about the solstices. This is one of 2 days of the year in which the sun's most direct rays are farthest north or farthest south. And I have a picture of Stonehenge in the background here because ancient people, they did pay very much attention to the motions of the sun. And part of what they discovered was Stonehenge is that it is to keep track of the position of the sun. And so at a certain position, or at the solstices, the sun shines through the structure of Stonehenge a certain way. And so this was one way that ancient people, for their different customs and thing, kept track of the motions of the sun and to keep track of the seasons. Because they're a very important thing to keep track of for planting and different things. But they also, this culture had a worship of the sun as well that involved that. And it marks the beginning of summer and winter. Now, the June solstice, and I'm not calling them, a lot of times we call them summer solstice and winter solstice. I am not doing that because the seasons are flipped for the northern and southern hemisphere. It depends on which hemisphere you're in. So I'm going to call it the June solstice. For the June solstice, the sun's rays strike Earth at a 90-degree angle at the Tropic of Cancer. So it's as if the sun is off to the left here. Um, and the Tropic of Cancer is this dashed line. I don't know if you can see it on the globe right here. Here is the equator. Here is 23.4 degrees north, or 23.5 degrees north, excuse me. This is the beginning of summer in the northern hemisphere, so it would be summer solstice for the northern hemisphere. And it's the beginning of winter in the southern hemisphere, so it would be the winter solstice. Now, also realize that during the summer and the winter, the extreme northern and southern parts uh, of our planet, the Arctic Circle will receive periods of time when there are 24 hours of light. And in the southern hemisphere, the Antarctic Circle, there will be 24 hours of darkness for periods of time. The December solstice, this is when sun's rays strike Earth at 90 degrees at the Tropic of Capricorn, which is 23.5 degrees south, which would be this dashed line down here, okay? And this is the beginning of winter in the northern hemisphere and the beginning of summer in the southern hemisphere. And so it would be the longest day for the southern hemisphere, it would be the shortest amount of daylight. Actually, days are always 24 hours. So the most daylight for the southern hemisphere, the most darkness for the northern hemisphere, and definitely 24 hours of dark for the Arctic Circle, 24 hours of light for the um, Antarctic Circle. And an equinox is a point in Earth's orbit at which the sun crosses Earth's equator, causing the hours of day and night to be nearly equal everywhere on Earth. And again, just Stonehenge in the background because it was a calendar of sorts to keep track of these events. And it marks the beginning of spring and autumn. Now, at this time, the sun's rays strike the Earth at 90-degree angle at the equator. So right here, it's right on the equator. So it's as if the sun is out of the screen or behind the screen for this that you're looking at. That's how the position of the sun would be to be striking at a 90-degree angle at the equator. There's a March equinox. And then the northern hemisphere, we call this the spring or vernal equinox. And it's going to be the opposite for the southern hemisphere. And in September, there's an equinox. And in the northern hemisphere, we call this the autumnal equinox. And like I said, this would be the vernal equinox for the southern hemisphere. So they are just switched. So if you're listening to this video, I want you to write next to your name your favorite season. I want to know your favorite season. So our objectives were to model the way in which Earth's tilt and revolution around the sun cause different seasons, and identify Earth's primary lines of latitude, which are the equator, the Tropic of Cancer, and the Tropic of Capricorn, and differentiate between a solstice and an equinox. Don't forget your 5 questions, and that is it for the chapter. You have everything you need for the test.